Hello everyone, thank you for being here. My name is Matt Pahacic. I'm a physical therapist with GL Rehabilitation and the founder of the Aging Gracefully class. I want to spend the next time telling you about a story of something I've been building. It's called the Four-Tiered Balance Assessment. It lives inside a digital tool called AG102.com, or AG102 for short. Before I get into the details, I want to tell you why this matters for me. Falls are the number one cause of injury and related death in adults over 65. 1 in 4 of us, 1 in 4 of you, 1 in 4 of me eventually will fall this year. Some of those falls will be small. Some will change one's life forever. Balance problems are a single biggest predictor of who's going to fall and who doesn't. And yet, the most clinics test balance is pretty simple. And they ask people to stand on 1 foot. They start a stopwatch and write down how long you last. And that's it. They might ask you to walk a little bit and come back down and sit in a chair. But it's limited. Number one, they're supposed to figure out who's at risk and what kind of exercise you should do and whether you're getting better or not. I'm a physical therapist and I've done thousands of exercises and balance tests. And I'll tell you what, number one, that one number doesn't tell you nearly enough how long you can stand on one leg. But I built something different. Something that actually looks like a 3 different sensory system your body uses to keep you upright. That figures out which one's going to be the most meaningful for you and which one's going to help you refrain from slipping. That's what this presentation is all about. Over the next hour, I'm going to walk you through my clinical thinking and behind these systems and how I built it, how I tested it, and importantly, what it's actually going to do for you when you use it. By the end, I'm going to hopefully have you understand this tool and what's underneath the hood, but not just trust it. I told you and I built it, so I make sure you know how it works. So let's get started. Let me tell you what we get wrong about testing balance. If we ever had a physical therapist or doctor check your balance, here's how that usually goes. They ask you to stand on one leg. They look at a stopwatch. When you wobble or put your foot down, the timer stops. They write down the number. That number gets compared to what's typical for your age and gender and match. And that's your score. Simple, right? Quick and easy. But here's the problem with that approach. Standing on one leg isn't one skill. It's actually 3 different systems in your body working all together at the same time. Let me explain. Right now, even while you're sitting in that chair, your brain is constantly checking 3 systems of information to figure out where your body's in space. The first system is your eyes. Your vision tells your brain where you are relative to the floor, the walls, the ceiling. And that's why most people are most stable with is their eyes open. With their eyes closed, that's a different situation. The second is your inner ear. Deep in your skull, behind your eardrum, there are these tiny little canals filled with fluid. When your head tilts even a millimeter, that fluid moves. And little hair cells inside your ears to detect that change. It's at the carpenter level built into your head. The third source is what we call proprioception. It's the awareness of your body has in itself without having to look. Close your eyes right now. Try to touch your nose with your finger. You can do it. That's proprioception. Your nerves in your muscles and your joints are constantly telling your brain where your body is in space. All 3 of these systems work together every second of every day. When you're standing on one leg, all 3 are firing at once. Now, here's the part that changes everything. Imagine 2 people. They both stand on one leg, and they both last 18 seconds. Same score, same age, on paper, they're identical balance. But one of them is heavily reliant on vision because her inner ear has slowed down with age. The other is a perfect inner ear function, but lost some sense in their feet because of diabetes. Same score, completely different problems, and here's the important part. They need completely different training. The first person needs to practice with her eyes closed to train the systems she's not using. The second needs to practice on uneven surfaces to wake up her foot senses. If all we do is write down 18 seconds, we've lost the most important information about how to actually help these people. That is the problem. Number one number cannot tell you what's exactly happening in your balance system. And without that information, we're guessing at exercising. The 3-tiered, and now made 4-tier balance system assessment was built specifically to solve this problem. Let me show you how. So if balance is a 3-tiered system, vision, inner ear, and body's awareness, how do we figure out which system is doing the work? The answer is pretty elegant. We take them away, one at a time, and see what happens. This isn't a new idea. Physical therapists have been doing variations of this for 40 years. We call it sensory integration testing. What's new in the system is how we structure it and what we do with the results. Here's how it works. We do 3 balance tests. We call them tiers. Tier 1 is the easy one. You stand with your eyes open. All 3 systems, vision, inner ear, and body awareness. When working together, we measure how long you can do a single leg stance, but that's only one aspect. You have to do standing next to each other, having sternum tandem. There's lots of variations we can do with this. And this is your starting point. It tells us what you can do with everything available. Tier 2 are the same for physical positions, but your eyes are closed. Taking vision off the table. Now you have to only have your inner ear and your body's awareness to keep you upright. If you could only you lasted 30 seconds with your eyes open, but only 5 seconds with your eyes closed, that's a huge signal. It means you're heavily leaning on your vision, maybe more than you realize. Now, the important aspect, it's not a bad thing lots of older adults rely on vision. Their eyes are sharp, and inner ear has slowed down with age. That's perfectly normal, but knowing this change about how you should train, if your vision is doing most of the work, the training needs to have not more single leg stance with your eyes open. That training you are already working with. You have to practice the things that are difficult. So practicing with your eyes closed on stable surfaces to wake up the other systems. 3-tier is the hardest one. Your eyes closed again, but this time you slowly turn your head side to side or up and down. Now we're not just taking vision away, we're stressing your inner ear at the same time. When your head moves, your inner ear has to work harder and to keep up. If you can still hold this position, your body's awareness in your ankles and feet and joints must be very good, because that's all you have left. If you can't hold it, we learned something specific. Your inner ear may be doing more work than we thought. So 3 tiers, each one removes another sensory system. By the time we get to all 3, we know exactly which system is doing all the work and which needs more training. Now here's the key. The pattern matters more than anything, any single number. If your number drops a lot from tier 1 to tier 2, that points out vision. If it drops more from tier 2 to tier 3, that points out your inner ear. If you're below average across all 3 tiers, that's a different problem. Your whole balance system might need attention. And if you're consistent against all 3, even if you're great, even if you're not great, that's actually a healthy pattern, because all 3 systems are pulling their own weight. Most importantly, that pattern tells us what to train. Vision dependent, you need eyes closed practice. Inner ear concern, you need a head movement work. And vestibular rehabilitation. Consistent across all 3, you need progressive challenge, longer holds, harder positions. 1 test, 3 tiers, 4 different training directions. That's the diagnostic engine, everything we built on and what are we based on. Before any of that could be made, though, we had to do a lot of deep dives, trying to make sure we have a standardized information, and then make the architecture and make sure we have a procedure going forward, so we can always be accurate with our information. Before we look into the implementation work, the actual code being written, I want to take you behind the scenes from where the project really started. Not the keyboard, but a stack of research papers. Phase 1 was the research deep dive, about an hour and a half of focused work, reading peer-reviewed scientist studies, and figuring out what each would mean for aging gracefully 102. I want you to understand why we did this before any code was written. This is the real temptation in software development. Just start building. You feel productive. You see the results. But for the clinical tool, a tool that is going to tell people their balance, comparing to their other ages and genders, and recommend what should be going based on what we observe, that kind of tool, we can't just start building it. We need to show the evidence. So phase 1 was all about reading. Careful reading and more making sure we understand it critically. So there's many different aspects that are getting written, and a lot of them is based on 6 different peer-reviewed data. We pulled information from the CDC study protocols, and what came out of phase 1 was 180-line research document. It has tiered boundary tables telling what normal is for different age and gender. It writes formal definitions of what it means to be a balanced master and different achievements we are logging, and the rationale before the asymmetrical flag. Why do we flag differences between 5 differences or more? Now, why does it matter? Why can't we just start coding? 3 reasons. First, we have to deliberately anchor to healthy older adults, not clinical patients. That's a lot of research is based out there on individuals with diseases, but when we don't compare to people in the hospital with diseases, we want to make sure we're going and striving to be that healthy individual. Our audience is mostly healthy, and they deserve to be compared to their peers like themselves. Second, phase 1, it sets the scientific tone for everything else. Once you commit to citation grounded reasoning at the start, every decision after that has answerable to evidence. There's no shortcuts, there's no gut feel. You just go with what the research says. Third is the auditability. So anyone who has access to these documents can trace the clinical claims back to the source. If you're a researcher or another clinician looking at the AG102, you can verify our work. That's a different kind of trust than just trusting me on it. Phase 1 was unglamorous. No code, no screen, just reading and synthesizing. But that's where the credibility of everything else gets established. So let's walk through each of the 6 studies in detail. These aren't background citations, these are the bedrock of the system was built on. Springer et al. In 2007 was a primary reference with Tier 1 and Tier 2 boundaries. That is, eyes open, eyes closed, with single leg stance. They tested 5 individuals aged 18 and up. And from there, we have to go through aspects of people who are older, so as we go to behind 2006. So that brings the boundaries for Tier 1 for anyone above the age of 60. Now, behind is updated this much larger meta-analysis. So it has refined, making these individuals up age 60 and above much more robust. Now, throughout this, there's other aspects where we need to know from the CDC study, Stop Elderly Accidents, Deaths, and Injuries, is the federal protocol for fall screening. The CDC's 4-stage balance test established the position progression, side-by-side, tandem, and single leg stance. Study also establishes the 10-second cutoff for falls risk, meaning if you can't hold the position for tandem for 10 seconds, that's a clinical flag. Notice that these studies have in common they're all peer-reviewed. They all have substantial sample sizes. They're all directly addressing the kinds of clinical questions AG102 is asking. They're not only sources we draw on, but they're the 6 anchor of most consequential clinical claims. Now I want to show you the actual numbers that came out of phase 1. This is the tier boundaries, stratified for what it looks like in practice. The balance averages sharply drop starting at age 60, 27 seconds for ages 60 to 69, then 17 seconds for ages 70 to 79, and then 8.5 seconds for 80 to 85. Consider 2 people having 20-second stance holds. For a 20-year-old, this is well below the 43 to 44 second average, potentially signaling a clinical issue. For an 80-year-old, that 20 seconds is exceptional, placing them in the high percentile. Using a good balance threshold would ignore the vastly different clinical realities. Age stratification is essential for accurate interpretation. This is why phase 1 focused on peer-reviewed data, such as Bohum 2006 meta-analysis of over 3,000 older adults, and Springer et al. 2007 study of over 500 adults. These findings ensure that every AG102 participant's percentile score is grounded in evidence. The third major piece of phase 1 was the achievement hierarchy. 4 levels: steady state balance, master balance, balance champion. We walk through each one so you can figure it out. So steady start. To earn this, you have to hold the single leg stance for Tier 1, which are eyes open, head still, for an average of 30 seconds on both legs, symmetrical. Then balance adapter is next. Same criteria, steady start, bilaterally, 30 seconds, with hand support level D or better. And you have to do that for both Tier 1 and Tier 2. Eyes open and eyes closed. And then balance master is so harder yet. Now you have to have all 3 tiers 30 seconds and above with level hand support level D or above. And then balance champion is have to do all of the 3 tiers, and you cannot touch with your hands, level E. Now, I want to pause to emphasize 3 things about this design. First, the bilateral requirement requires B on both sides, not just one. Why? Real world situations, you can't choose which leg you're gonna catch on. You have to have both really well. The 30-second threshold is not 20, not 60, because 30 is the upper end for healthy adults. And most of the research literature combined with the bilateral requirement, so you're capturing consistent capability, not just a lucky one trial. Third, we have the hand support, and we define level D with just occasional touching. And all these are going to be formalized before any code is written, because that was important. You can't. So when you see your level in AG102, you're seeing something carefully designed, not arbitrary milestones. Phase 1 gave us the research synthesis. Phase 2 was about taking the research and writing it into the Aging Gracefully 102 official clinical reference document. We call it V9. It's V9 because there's 9 different versions of this. This is a massive document, and pretty much it is going to be the source of truth. Anything that is in this document is why we're doing the things we're doing. So I had my AI agent go and do research of this topic and how to automatically update this aspect, and we figured out the protocol. As soon as we do any deep dives and clinical research, we need to make sure we update this aspect. So we had 5 changes that are going to be changed out of phase 2 in this document. 3 out of the 5 were depreciation banners. We marked the old stage 4 balance sections as depreciated. We marked the old stage 3 and 4 extensions as depreciated. We have the single leg information depreciated. The 3 legacy sections all replaced with a new 3-tiered system. And then the 4th amendment was a big one, was the new 3-tiered balance system itself. There's about 280 lines of detailed specification, computed tiers, boundaries from the research, formal achievement hierarchy, the asymmetry flag, the hand support guidance, and definitions. The 5th was the cross-reference, and throughout this, we had over 320 lines added to version 9. Why does it matter? We should make sure as soon as we do the research and change something, we have to document it. Because this is going to be a live document, and we're going to constantly make changes to it. So, future maintainability. If someone joins this year and wants to understand why the balance master requires level D, we can read this document, give them the rationale. I don't have to reverse engineering any clinical reasoning from the code. We have this massive document that does it for us. It was unglamorous work. It was 45 minutes of writing. Without it, every line of the code came later. Be less defensible. Let's take a second to go through each of the 5 amendments just a little bit more in depth. So the depreciation banner, so A through D are all going to be depreciation aspect. So we have to rewrite some of the aspects. We had this document created multiple times, so this was the recreation of this, and we had the old aspect. So we have to make sure we're changing what was in the code and how we are changing definitions of each one based on what the website's going to be like. So we rewrote the 4-stage balance, the higher tiers of 5 and 6,
single leg progressions and try to make sure the symbol control. And then we tried to make an add. It was a new section itself. This is like where most of the writing happened. So the clinical rationale for the three-tiered approach: why 3 tiers, why the specific progression, why eyes open first, then eyes closed with head movement. All explained in the next session. The 5-position progression, side by side, semi-tandem, tandem, and single leg. Those different positions, because we had forward and the left and right, all came from the study protocol. And now we're kind of using it and throughout our process. Now, also making sure we have the age, gender norms in there as well. And then we have the aspect where we're going to have that new change after all this is going on is 320 lines to version 9. And it took a while to do it, but we got it done. Phase 2 also defined the 5 databases and what we call the test IDs. These were labels we used in the database to keep kinds of balanced data organized. Then we rock through each one in a matter of how phase 3 schema worked and could happen. First, test ID, balanced tier 3T underscore tier 1. This was the raw data from tier 1 testing. Eyes open, and the test structure captures all 6 positions. And then we have the aspect of what kind of hand position was going through each one. A, B, C, D, E. The second was, now for tier 2, same structure, different content, because now it's stored when you had your eyes closed and head still. Same aspect, what you had for each of the P position, what you have for each of your hands up position. And the system did not assume we still need the same level for both aspects. And so on forth, we have level 3, and then we have eyes closed with head turning, same concept, the hardest one. And then we have those 3 test IDs, tier 1, 2, and 3. That's the raw data. They're what the user actually did. The 4th was the achievement level. This is different. It isn't raw data, it's a computed state. And I explain the difference because it matters. Raw data is what we collected and what the person inputted in there. We held the position at 12 o'clock in the morning with the eyes open for 28 seconds on the right leg, 32 seconds on the left leg with level D support. That's raw. Then we computed that data, and based on the number, the user is at the balance adapter level. We didn't measure that, we calculated that. The balance 3-tier achievements stores at a different level: steady state, balance adapter, balance master, and balance champion. It also stores a specific criteria if you met it. For example, tier 1 single leg, both 30 seconds, is true. Then the tier 3 single, then that's going to allow you to get a better granular detail and actually unlock something. It has asymmetry flag, so if it exceeds 5 seconds from single leg stance, left and right, then there's going to have a flag. And then there's going to also be a century state. So based on the different tiers, if you are more visual dependent, more vestibular sensitive, multi-system balanced, and so there's just different ways of clinically identifying yourself. So 3 test IDs for the raw, 2 computed states. Why split it that way? Why not just store everything in one place? 2 reasons. First, the raw data is the source of truth. Is our achievement algorithm ever had a bug, or the clinical criteria needs to be updated because on the research, we can rerun the algorithm on the stored tiered data and update the computed state. We don't lose anything. The raw data is still intact. Second, performance. The dashboard needs to be displayed. You are at balance adapter level. Quickly, reading one row from the achievement test is faster than parsing all of the 3 tiers at once. So we pre-computed and stored the results. The separation of the raw versus computed is one of the cleanest design patterns in software engineering. It comes up again and again in well-designed systems. Phase 2 brought that into the AG102 pattern. Alright, Phase 2 also formalized something that I think shows you the intellectual honesty of this whole project. The hand support gradient. Most balanced research is simple distinction. With support, without support. Did you touch the wall? Did you not touch the wall? 2 states. That's not nearly granular enough for real clinical work and real life. Explain why? Imagine 2 people doing single leg stands. Both technically use support. The first person held the leg back of the chair with both hands the entire time. They essentially leaned on the chair while their leg was off the floor. The second touched the wall briefly, once for less than a second, because they felt a little wobble and they reset. Clinically, it would be use support, but completely a different reality for these 2 individuals. So AG102 uses a 5-tier granular support, so let's walk you through each one. Level A is heavy support, hand support. For an entire time, you're holding on to it firmly. Level B is going to be moderate support. Sustained light pressure, so you're not white gripping anymore. And maybe just some fingertip support. Level C, light support. Intermediate contact for safety. You touch the wall periodically to reset. But it's only brief. Then level G, touch support. And this is operational defined very well, and we actually have people defining and saying how many times they are touching for those 30 seconds. So you cannot touch more than 5 times per that 30-second trial. Each touch must be less than a second in duration. This is essentially a fingertip only contact, just a little bit of aspects. We call this a safety touch. The level E is finally the independent. No contact whatsoever during the whole time. Hands aren't in contact with anything. Now, here's the part that matters. Here's the intellectual honesty part. Phase 2 documents the whole 5-tier level. Transparency as aging greatly 102, clinical optimization, not as externally validating research data. Let me explain what that means. There's no published data on this. Say there's a typical time differences between level A, B, C, all the way through E. There's no study that exists. This is my clinical reasoning saying we need some way of helping this process out to help the individual figure out how much assistance they're using and how is it going to be meaningful for the adult. We could have hidden that fact. We could have presented the granulate as I backed by peer-reviewed studies, but that'd be misinformation. Instead, we're doing the honest thing and saying this is based on clinical expertise, and it is. But the thing is, this information has been grounded in aspects of support or no support, and so we just made it a little bit easier to have that leveling up system. Why does it matter? Because in clinical practice, you don't want you to know if you are just reasoning out, mixing up the leads over the confident claims, hurting people when they turn out to be wrong. Phase 2 made the commit that kind of honesty every later phase will live on. Phase 3 was the architectural design session, taking the version 9 specifications from Phase 2 and turning into a concrete database design. This is the most technical and foundational phase, but it's worth understanding because the decisions made here affect how systems perform and are maintained over the years. This session was about 20 to 30 minutes of focused architectural design from AI agent to storage patterns around the table. Pattern 1, a composite JSON rows. The ideal was one database per row with entry tier. Inside each row, the full tier data, all 6 positions, all 6 trials, and support level, each stored on structural JSON objects, 4 rows and computed systems, 3 for each one, plus the achievement level, or 5 rows and including the entry profile. Part 2, flat rows. The ideal was one database row per trial, 6 positions, 3 trials each, 3 tiers. That's 57 rows of trial data alone, plus more of support levels and metadata. Maybe that's 60 plus 4 per assessment. We chose pattern 1, produced a schema design, document specificity, exactly how the JSON inside each row should look. Why pattern 1? 3 reasons. Reason 1, database growth. Let me walk you through this. Suppose a user does balance assessment quarterly, every 3 months, for 5 years, that's 20 assessments. Pattern 1, flat rows, that would be 60 plus rows per assessment, that times 20, that would be 1,200 plus rows for that one user. Now multiply that by all the users, the database grows fast. On pattern 1, the composite JSON file, that's 4 or 5 rows per assessment times 20. So that same is only 80 to 100 rows for the same user, an order of magnitude less. Why does a database size matter? Because performance degrades as the database grows. Queries get slower, backups take longer, storage costs increase. The small, more compact pattern stays manageable. The second reason, the clinical grouping. Think about how a clinician interprets balanced data. They don't think trial 2 of position 4. They think of tier 1, eyes open. They think of tier 2. So it is just the aspects of how the clinician would work. The third reason is pattern consistency. AG102 already uses composite JSON storage for the older stage 4, so now the pattern extends to the new system. Now, so by the end of phase 3, the implementation team is trying to find the specificities to build against. No more design and ambiguity, just engineering. That's the whole point of this. So as we talked about before, I want to spend a little time discussing why we chose the 4 tier versus the 60 tier, and just for the aspects. We talked about the numbers, but here's the slide that actually gives you the numbers on the slide. It just makes more sense as we get into later on into this project. We're going to have a lot more users, and we have to make sure we don't have these huge databases with lots of rows, because that increases costs and slows down the system. So this compact version is a much better, and as way we do this as a clinician, we don't view each individual as separate. We want to group things together as century tiers. Phase 3 designs something subtle but important. The achievement row is now stored in separate designs entirely. Even though it's derived from the the tier data. Let me explain why that matters. On the screen, you'll see some JOSN structure of the three-tiered balance achievement row. Now let me read through it. The level field, the current achievement. In this example, it says balance adapter. It tells you the user that has met the balance adapter criteria, but has not yet earned the balance master. The compute at field is timestamp showing exactly when the achievement was computed, May 14th, 2026. Why does that matter? Because if the bug fix changes how the achievement gets computed in the future, we can rerun the algorithm, and the timestamp tells us when each achievement state was calculated last. The criteria met object. This means where it gets really useful. Each specific criteria gets a boolean, true or false. Tier 1, single leg, both stands 30 seconds, true. Tier 1, level D or higher, true. Tier 2, single leg, both legs for 30 seconds, true. Tier 2, level D higher, true. Tier 3, single leg on both legs, 30 seconds, false. Was it hand support? Level D, false. So that gives you a specific criteria, yes or no, at these things to get you what you need to have for these different achievements. Why store the criteria individually? Because it's a user interface tells you exactly what you achieved and what still needs to do. You've met tier 1 and 2 criteria. To earn the balance master, you still need to hold single leg on both legs on tier 3. Specific feedback, actionable feedback. Now, an asymmetrical flag. So if you're more than 5 seconds between that's right difference, it's gonna flag that in any tier. Now here's the question. Phase 3 had to answer. Why store the row at all? It is derived from all of the 3 tiers. Can we just compute this on the fly every single time someone takes off of the dashboard? 4 reasons we chose to store it. Let me walk through each one. Why? First, the dashboard performance. Reading one row from the database is faster than reading tier 3 rows and computing the achievements on the fly. We're talking milliseconds, but across thousands of dashboards, those milliseconds add up. Pre-computing and storing pays off. Second, audit trail. The computed at timestamp creates historical records of when each user achieved the level. If the earned balance master in January, they have a timestamp. If they reach balance champion in March, they have a timestamp. We can show the user their achievement history over time. We can analyze patterns across the user's database. The timestamp is the data. Third is the cross-surface consistency. AG102 has multiple places to show you the achievement level. The dashboard, the PDF feedback that you download, the pillar details, 3 different surfaces, and each surface computed the achievement independently. It could drift out of sync, especially if the achievement logic ever changed. Surface 1 would say balance adapter, but surface 2 would be balance master, and we didn't know what to trust then. By storing the achievement in one place, every surface reads the same value. Consistency by design. Fourth reason, and this is the most important one, is recompute hooks. Let me explain. Suppose we fix a bug in the achievement algorithm next month. But suppose new clinical research causes us to update the criteria. Or suppose you want to add a new sub-achievement. Say, the Sidler adapter between balance adapter and balance master. With the achievement state stored separately, we can rerun the algorithm on every user stored on the database and update the achievement levels in both one batch operation. No data loss. Their tier rows and the raw data are unchanged. The achievement state is the derived view, and the derived views from the regenerated spot. This separation, raw data versus computed state, is one of the cleanest patterns in software engineering. It cleans up everywhere. Phase 3 brought into AG102 balance work. I want to close out with one more thing we did in phase 3 design, and because I think it captures something important how we did the whole system was built. Phase 3 was designed as a schema to distinguish 3 different kinds of no data. The scenario that all looked blank space in your assessment, we have built completely different clinical meaning. Let me walk you through each one. Scenario A, not reached. The data represents a null, N-U-L, which is the computer speak for empty. The clinical meaningfulness of the one that did not. The clinically meaning is that the user stopped at a earlier position than the tier and never got to the farther one. For example, you start at tier 1, you do side by side, that goes fine, you do semi-tendon, you just fine, start with tandem, and left foot and forward is harder than expected, you give up, and you never complete the single leg. Your data has semi-tendon values, but does not have your single leg stance. It should actually be null. The system records that you stopped at tandem stance without judgment. You could not do that day. That information is preserved. Now scenario B is skipped, decline. The data represented the GOSN object. Skipped true object. User decline safety. The clinical meaningfulness is different than scenario A. The user reached the position in assessment is deliberately chose not to attempt it. For example, you go through tier 1, but you complete side by side, but you skip semi-tendon and tendon, go right to single leg. When you look at the information, you decided not to doing that today, but maybe if you don't have a safety reason, you just want to go a little bit faster through the test. So you hit a skip button on the bottom. That is clinically different than scenario A. Scenario A, you never got there. Scenario B, you got there, but you respected your own limits and you said, like, I'm not going to take my time to do the simpler stages. The reason field is executed. The schema supports several reasons. User decline for safety, provider recommendation not to attempt, equipment unavailable, time restraint. Each one has a slightly different story to tell. Scenario 3, attempted and failed. The data represents a trial value of 0. The clinical meaning is that you tried the position, but you cannot hold it at any time. Example, you try single leg stance, lift your foot, and lose your balance within a fraction of a second. Try again, same result. This did not attempt. This is an attempt and physically could not hold it. This information preserved indifferently. And all these 3 different distinguishes these 3 different aspects. If your physical therapist is looking at your assessment, the difference between never reached, skipped, or unattainable are completely different. And it tells you the first one might mean fatigue or hitting a ceiling earlier than the progression. The second is good clinical judgment for your own safety. The third shows real monitors system, difficulty with warranting target intervention. So that's how we ended phase 3 with a data design of how clinically complex instead of flattening it. And that respect and that careful attention to clinical reality sets the standard for everything else was built on. Now let me show you overall shape of how we built. 3 days, 29 comments to the code base, 5 phases shipped to a real live website that people can use right now. I broke the work into 6 phases. I was going to take you through each one in detail as we go through the presentation. I want to see the big picture. And this is going to be just part phase 4, the foundation. Was the plumbing. Database was storing your scores, and the math turns out your time and percentage rank, and the achievement system that recognizes you for your accomplished, even if you didn't reach single X fans. We'll talk about achievements later, but most of us will see the features for results specifically. Phase 4B and through 4D were under interface and audio. This is the part you actually see and hear when you use a test. Voice prompts counting, so you don't have to fumble with a stopwatch. A clean way to see your results. Background work line, make sure the audio doesn't keep playing when you leave the screen. Phase 4E, and this is the one I have to take notice, was all the darn bugs and polishing it up. 8 subphases, rounds that are trying to figure out what's going on, diagnosing it. It was a headache. Phase 4F was expanding and collapsible features. Some of you might want to see a summary number. Some of you might want to see every single trial and performed, and this was the collapsible feature on the dashboard. Phase 5A, the Century profile is the headline feature, the part where it tells you your Century system is doing the most work. I'll spend a significant amount of time later because this is the most clinically meaningful. Phase 5B is freshness tracking, making sure it's recorded and what is going to be done. Now I'm going to be honest with you, software that is quickly getting built gets built badly. The real reputation in healthcare is half-baked apps, the promise of a lot of delivery, something is flimsy. That's not what we have here. Yes, this came together in some days, actually more than 3 days. It's like 3 weeks from start to finish. But every commit was reviewed. Every bug was diagnosed before it was fixed. Every feature was verified in real browser. After deployment, nothing went live without approval. It was a very systematic way of doing it. When you see the results in the tool, I want you to know that the path from this is my time on one leg to here's the Century system was built with careful review, not slapped together. Let me walk through phase 4A in detail because this is where everything else gets built on the top. Phase 4A has 3 pieces: the database, the scoring engine, the achievement system. Each one matters. First, the database. When you do an assessment in this tool, an enormous amount of data gets recorded. 3 trials at each 5 positions for both your left and right sides. Whether you support and how much, if you skip the position, why you skipped it, the exact time, your test, we all capture it. Why so much data? Because the average over 3 trials is more reliable than just a single attempt. Maybe 1 trial you wobbled. In the first second you put your foot down, maybe the third you really nailed it. The 3 trials put together give you a more honest picture of your true ability is on a given day. The second piece, the scoring engine. This is where your time gets converted into something meaningful.
If I tell you you held your single leg stance for 22 seconds with your eyes open, what good does that do? What is it? Is it good? Is it bad? Compared to what? Compared to the other people your age, there are 3 published research studies. Baum, Skinner, Michael, they all put together thousands of tests of older adults at various ages and recorded their balance and times. From this data, we know what typical is at age 65, 75, 80, 85, and beyond. When you do an assessment, your time gets compared to the age matched norm and converted into a percentile. If you're at the 50th percentile, you're right in the middle of your age. If you're at the 75 percentile, you're doing better than 3 out of 4 people. If you're in the 10th percentile, well, we have some work to do. And this is exactly the kind of clinical information that helps people and me as a therapist plan your training. The system looks at the difference between your left and right side. If they're close to each other, that's a healthy pattern. If one is more dramatically weaker, that's a flag that side might need more attention. Now, here's the third piece, and the one that matters the most clinically, the achievement system. Most balance tests are pass and fail. Either you hold the single leg stance for some number of time or seconds. You can or cannot do it. That's the framing. I don't accept that framing. Why? Because most every person I want to work with as a physical therapist has worked hard to get somewhere. Maybe they're not where they're supposed to be. Maybe they just got out of the hospital. Maybe they were recovering from an injury. Maybe they have a balance disorder that's been with them for years. If they walk into my clinic, they do their best. They walk out feeling like they failed. A failure over a tool, not a failure over a person. So we built the achievement system. 4 levels, a steady start, builder, climber, champion. You can earn achievements in any positions. If you hold side-by-side stance for 33 seconds, level E, with no hand support, that's a building achievement. If you reach a tandem stance, you're the champion. If you reach a single leg, you're a champion. Same data, same time, same percentiles, very different message. Here's why it matters. If you come into this assessment, the first thing the screen tells you failed, you're not coming back. You're not going to keep training. You're going to get discouraged. But if it's a screening test, it's supposed to say you're building at the side-by-side level. That's in starting point. That's something you can build on. That's how we keep people engaged in their own care. Phase 4A gives us all those pieces. The data, the math, the framing. With all 3, the rest of the system does not work. Phases 4B through 4D, we're talking about the foundation from phase 4A, entering into something usable. There's something to say in software development that I think also applies to clinical care too. There's a difference between something that works and something that actually you want to use. Phase 4A built something that worked. The next 3 phases make it something you want to actually use. Let's give a concrete example. One example, audio prompts. The first version of the tool required you to enter in time yourself to have a helper time with you. If you ever tried to balance on one leg, you're also looking at a stopwatch or the phone screen. You know how impossible that is. You're not balancing, you're perfectly watching the clock. So we built an audio prompt. The system uses voice to tell you where to start, counts down soundly, and gives you a periodic feedback. It tells you when to stop. You don't have to look at it at all. You just have to stand and listen. And that's important.
When you navigate away from the screen, the audio shuts off. When you come back, it picks right up where you halfway through the count. Sounds simple, was not simple to build though.
Example 2, navigation memory. Older adults often have different relationships with technology than younger users. If you ask your mother to use a new app, the first thing she does is poke around, tap on things, see what happens, come back, go elsewhere. The screen jumps back and forth to the screen every time. She gets frustrated. She thinks she's lost in a place. So we built something called anchor scrolling. When you click on the stability pillar to check your results, the screen opens to where you last looked. If you checked Tier 2 data, come back to Tier 2. The small thing but huge difference. Example 3, the consolation view. Before this phase, your balance information was scattered. You might find Tier 1 in one place, single leg times in another place, your percentile score in another place. We built it all in one model. One consolidated screen that shows you everything about your balance in one place. Tier headers, single leg times, percentile scores, and date you took last test, all in one view. Now I want to emphasize why this all matters. In healthcare apps, so there's a lot of healthcare apps out there, and a lot of them work, and a lot of them get abandoned by patients in the first couple weeks because they're frustrating, confusing, or just don't fit how older adults actively use technology. Phase 4, B through D, was specifically about not falling into those traps. The technology works, shows us clinicians benefits, hands-on users, predictable behavior, everything in one place, no flickering. That's not luxury. That's what makes the difference between a tool that keeps people using it instead of being digital paperweight. Phase 4E gets into its own slot because it deserves it. 4E was testing and refining chapter. 8 subphases, each starting with someone, usually me, trying to use what we were trying to build, and something went wrong. Now, I want to be honest with you. In healthcare, there's a temptation to pretend that tools never work perfectly the first time. Tools work perfectly after rounds of fixing it, and you don't practice something to get it right. You get practice until you kind of get it wrong. Phase 4E was 3 days of finding and fixing the real problems. Let me be specific examples. First, we found the percentile calculation was producing a meaningless result. We started a trial that didn't complete the 3 repetitions before saving the math behind the scenes, which tried to average a number that wasn't there. You'd see NA. Short is for not a number on your screen. For a clinical standpoint, this is a useless result. For a patient's standpoint, it is confusing and disturbing. We fixed it, so it was awesome. There were multiple problems, I'm not going to go through all of them. But each of these was a bug. Each one was diagnosed before being fixed. Each fix was verified in a real browser after deployment, before declared complete. Phase 4E wasn't glamorous. It wasn't new features. It was careful, methodical work of finding what didn't work and made it right. Here's the thing about clinical software. Most of it gets built and shipped fast. When users hit a bug, they stop using it. The path to the tool you can trust and pave. These small little unglamorous fixes, 8 rounds of them, fixes all of them. Now, let me show you 2 of the more interesting features that came out of 4E. Now, there's 6 specific things we fixed in 4E, and each one has a real bug that the users might find. And these specific things will help make this a polished abstract. Bug 1, the percentile, that's was not a number it came out. And so it was very meaningful, and it was irritating that it was coming, but we fixed it, and we were able to figure out how to make sure it knew how to do it. Bug 2, the cursor focus loss. This is the kind of bug that drives older adults away from technology. Carefully typing a number in a box, and the cursor jumps around out of the box. Retyping goes nowhere. You start over, and the cursor jumps again. So figuring out how to anchor that. Bug 3 is the plateau handling. There's a little bit more technology. The normative data from the research isn't completely smooth. Sometimes you have seconds between 12 to 15 where you kind of make the aspect. So try and normalize the data, because the data is messy, from the research, how to make it clinically meaningful. Bug number 4, the Tier 3 information labeling. Here's the thing about Tier 3, which is eyes closed with head turns. There's not a lot of published data on this, and variations in older adults especially. We capture the data because it's clinically useful. We don't have the same kind of reliable percentile tables for it. Originally, we tried to make up a percentile anyway. That was wrong. I'd rather tell you honestly, we don't get these norms from tests, and we tend to have them. So we changed the label to informational, meaning we recorded your time. You can see it, but you're not using it, pretending you have exactly the rank next to gender and age-based norms. Bug 5, latest data sourcing. This is a seriously clinical bug. If you did a new balance assessment today, then went into your dashboard tomorrow, you might see yesterday's data. The system wasn't always pulling the most recent assessment to each tier. Imagine a blood pressure machine sometimes showed you the last month's reading instead of today's. That kind of bug. This was the kind of bug that was. And we systematically fixed it always with the latest assessment. If you did level 1 yesterday but did tier 2 today, then you would show yesterday's tier 1 but then today's tier 2. And that's the right behavior. Bug 6 and the final and last one is the testing instructions. Different testing instructions have different safety considerations. You shouldn't do eyes closed work without a wall nearby. You shouldn't do head turns if you have certain ear conditions without physical therapist approval. The instructions help figure out how to do it safely. 6 bugs, 6 fixes, each one in the public code repo, each one verified after deployment. The point I want to take away is, when you see this tool, you see your results. You're seeing results that have been through careful testing, and that's hopefully you can trust. Phase 4E through B is exactly what I think is one of the most important features in the entire tool. It sounds technical, but actually, let's actually talk about it. Here's the issue. Single leg stance is the hardest position in the assessment. If you hold single leg stance for 30 seconds with your eyes open, you're usually doing very well for your age, and that's an accomplishment, an achievement. But, and this is what really matters, many older adults won't be able to hold single leg stance in their first assessment. Maybe one had a stroke, maybe has arthritis, maybe you have a vestibular disorder, and they're still recovering from a hospitalization. There are hundreds of legitimate reasons why someone might not be able to do single leg stance. Before phase 4E through B, the system only displayed your single leg time in the tiered headers. If you didn't reach single leg stance, you didn't get shown nothing. Empty spaces where your achievement should have been. Think about what that communicates. Stay at home, you complete your assessment, you reach tandem stance, which is really great, held it for 25 seconds, which is a real achievement. and the dashboard tells you nothing. That's wrong, that's clinically incorrect, emotionally wrong, and we fix it. Now each header tells you the highest position you achieved and what support you have. For example, tier 1, eyes open, 10 level, you reach tier 1, eyes open, you reach tandem stance with level 4E, that is no hand support whatsoever. And that shows up on your screen. That's accomplishment is recognized. Let me explain the level letter means. So when you're doing your balance test, we have different amounts of support, A through E, for how much hand support you have. Level A is the heavy support. You have a lot of hand support, and then as you go through, it gets less and less and less. And level D, you have to touch it once in a while, and actually graded on that. And you actually have to check a box like how often you touch it, because that's a very meaningful aspect. Then level E is just you have no hand support whatsoever, which is great. Now, there's no normative data on this, but this is how people can make things harder by changing your foot position, changing your hand support, and that's important. And you can change your eyes, and we already talked about it. So this is just another way of gating how well you're progressing through your different systems. This is what we call clinical accuracy without patronization. We're honest with you about you earned your result. We don't hide the fact that you support if you did, but we also didn't make you feel bad about it. We don't pretend that all support is the same. Before that got coded, I had a conversation that went through 8 separate design subdecisions. How should we handle the tier look? How should the text show? What levels should show badges? What should the badge text say? Where should the badges appear? 8 discussions. Each talked about a different clinical reason before we got the code written. And I want to take this away. When you see the tier headers, you see the support badges in the tool. These aren't arbitrary design choices. These were carefully decisions that we communicated and made sure we were accurate and respectful. I'm going to spend a little bit more on hand support level E gating because it's actually a clinically important decision, and I want to make sure you understand it. Here's the thing, the whole reason we can give you a meaningful percentile score is that there's published research telling us that the typical at your age, the research use specific methods. If you want to compare your results to their data, we have to respect their methods. The 3 big research studies we drawn from collected thousands of older adults from different ages. They wrote up their methods carefully. They specified participants could hold themselves near a wall or a chair. For safety, the research were measuring balanceability, not measuring bravery. They didn't want anyone to fall during the test. So the researchers allowed a touch support fingertip on the wall, light contact for support. That's part of the protocol. This is actually important for interpreting their data. Let me explain. If you held single leg stance for 25 seconds at level E, fully independent, your result line up perfectly with the research norms. People can commonly say you are the 60th percentile for your age. If you held the single leg stance at 25 seconds at level D, meaning you had fingertip support on the wall, occasionally your results still line up with the research norms because of that level of touch support the researchers permitted in their studies. We can still say with confidence you are at the 60th percentile for your age. But if you held the single leg stance for 25 seconds at level A, B, and C, that's significant hand support. The raw time is still meaningful. We know you held your single leg stance for 25 seconds with help. That's important. Comparing the research database where participants had the most fingertip support, and the comparison overestimates the true ability. So, now I want to be clear about something. These badges are honest. They're not punitive. They're not designed to make you feel bad about using support. Using support is a smart thing to do for safety. The badge just makes you sure you want to see your percentile. You have to get full context. This is exactly the kind of decision and thought a physical therapist makes all day long. Yes, my patient has hit a milestone, but they have to get awarded for that. So I have to write that in my notes. We have to build the same clinical thinking systematically in this tool. When the support badge on your data, you are seeing the equivalent of a careful clinician's note and a sign that's clinical rigor, not a sign that something went wrong.
Phase 4E/C added 3 improvements that made the assessment experience itself easier and more flexible. These might sound small, but they added up to be a much better experience. The first was a skip tier button. Let me describe the problem this solves. Imagine you start tier 1, you complete it a couple of positions, maybe you reach tandem stance, and then you're done. You're tired, your knee is bothering you, or you just feel like you don't want to go any farther. It's not going to be a useful thing to do. Before phase 4EC, your options were you save the data with the remaining positions empty, which is confusing. Do you try them at all? Do you fail? Do you not try at all? Or quit the session entirely, which lose everything? There's a third option, and that's a skip to tier 2 button. One click, the system records that you deliberately chose to skip the remaining positions. That's important. Your physical therapist is looking at the data later, and they see you made a deliberate choice to stop, rather than see missing data and wonder what happened. And here's the thing, you should be allowed to stop. You're the expert of your body. If you decide further attempts are not safe or useful, the tool should respect that decision, not penalize it, not make you feel like you failed. Just record the choice that you made and move on. The second improvement was the position chip navigation. At the top of each tier, you can see the 5 circles representing the 5 positions, side by side, semi-tandem, 2 tandem, and 2 single leg stance. Previously, you have to walk through all of them in order. If you finish side by side, then you do semi-tandem, then you do tandem, you see the pattern. And you couldn't go adjust it as you quickly go through it if you wanted to. Now these chips are clickable, you can jump anywhere, forward or back. If you go back to a position you already completed and the data, that data automatically pre-fills with that data you had. You don't have to retype everything else. You just adjust the number that you want to change. There is a safeguard as well. If you started entering data but haven't entered 3 trials in yet, the system blocks navigation away from that position with a friendly message. Please enter all 3 trials or leave all blank. This prevents partial data problem we talked about earlier. The same thing, small thing, big improvements in the user experience. The third improvement was the per tier breakdown. That's this one more about how you see the data later and how you enter it. When you click on the single leg result on the dashboard, you'll just see that your mean, your average across the 2 trials. Now you see more data, your best trial, your mean across all 3, your range from worst to best, the individual trials themselves. Why does that matter? It gives an example of, imagine two people with the same average, 21 seconds on single leg. Person A has 21, 21, 22, very consistent, balance is reliable. Now person B, trial, 9, 19, 35, same average, wildly different reality. The person had one bad trial, one moderate trial, and one great trial. This tells us something is happening clinically, maybe fatigue, maybe learning effect, maybe a day-to-day variation worth investigating. Same average, different stories. The per trial breakdown lets you see those stories. Lets your physical therapist see them too. 3 small features, each one designed to respect that the user deserves flexibility and data, how you interact with your own data. Phase 4F added a feature that I really love. It respects the different people want different amounts of detail at different times. When you open up your stability pillar, you see headers that summarizes achievement by default. Those headers are collapsible. If you see a key, this is tier 1, eyes open, single leg reach, level D, clean, simple. But if you want more detail, you can click on an aspect and you can see it expands into a paragraph. Every support you used, full picture. Why is this useful? Because the right amount of information depends on the moment. Maybe you're a long time user, you've been doing trialing these balance things for months, you know the information like the back of your hand. You don't need to know how you did everything in the past. So he allowed you to see your behavior. Now, this is different to default for each state. Both default behaviors respect that user. There's a small but important thing the expandable view shows you. It distinguishes between two different states, a skipped, declined, or not attempted. If you deliberately skip a position, you click the skip button, it says skipped, declined. That is an active choice you made. If you never got to the position because you said skip the entire tier, it says not attempted. That's different. You decide to skip that position, not just you didn't reach it. This is the kind of polishing that takes time, and most clinical software does not bother with. We want to make sure we bothered with it and had improved the user experience. Alright, this slide I've been building up to the century contribution profile, which makes this entire system worth it. Everything else we've shown you so far in this serves of this. When you open up the stability pillar in the AG102 app or website, the very first thing you see above the tier data is single leg stance. The century contribution profile. Let me describe what you see on the screen. Next to the compass, there's the header. The name of the century pattern used is found. There are 5 possible patterns the system can identify. Let's go through all 5 so you have an idea of which ones they are. And below the header, there's also a date stamp. Why the date? Because your century profile changes throughout the time. So, going through this aspect, there's going to be some statement of the 2 interpretations in plain language for balance systems. The interpretation reads, performance was similar across the 3 century tiers, suggesting your balance leans on vision, vestibular, and somatosensory together. That's clinical language, but also plain enough that you can understand it without a medical degree. And then you have the numbers themselves, what you actually got. Now I want to take a moment to emphasize why this is important. Everything else in this assessment, every percentile score, every tier header, every single trial breakdown, all serves this conclusion. The century profile is the actionable clinical insight that comes from the data. When you go into a physical therapist, looks at your results, this is the guide you're training if you're visual dependent. If you need to track your eyes closed, vestibular sensitive. If you need head movement training and possibly vestibular rehabilitation referral, you're multi-system. You need to have a comprehensive evaluation and probably referral to a specialist. If you're balanced across systems, you don't need rehab at all. You need to just keep progressing your balance and maintain what you have. Distinct patterns, different training, and the pattern tells you what to do. This is what I mean when I say the tool is different for anything else. It's not measuring your balance, it's interpreting your balance in a way that's clinically meaningful and actionable. So the 5 patterns the system can clearly identify, let's walk through each one. Pattern 1, vision dependent. This is the one that most common pattern we see in older adults. You can hold single leg stance well with your eyes open, let's say 30 seconds on each side. But when you close your eyes, your time crashes, maybe only 5 seconds, maybe even less. What does that mean? It means your eyes are doing most of the work. You've been compensating for inner ear and proprioception changes by leaning heavily on vision. That's a smart adaptation in some ways. Your brain is using the system that works the best for you and is the fastest, but it also is fragile. If you trip in the dim light, if you move your head quickly, your balance can fail in ways that surprise you. The clinical action for vision dependent is to train your system you've been underusing. Foam surface standing is great for this. The foam reduces proprioception feedback, which forces your inner ear to work more. Eyes closed practice with a wall nearby for safety is also key. The goal is not giving up vision, it is to make the other systems rise up so you're all working together as backup. Pattern 2, vestibular sensitive. This pattern shows up differently. You do okay with your eyes open. You do okay with your eyes closed, but when you add head turns to your 3, your time crashes. This points out your inner ear. The vestibular system in your inner ear is what helps you stay upright. And when you move your head, you're not as strong as it should be. And you're compensating by holding your head very still. But add movement, that compensation breaks down. Clinical action, vestibular rehabilitation. The whole subspecialty of physical therapy dedicated to this. Vestibular PT exercises include called VOR or vestibulo-ocular reflex training, gaze stabilization, head turns while walking. There is good evidence that these exercises improve vestibular function in older adults. And here's the flag. If you experience dizziness, lightheadedness, nausea during Tier 3 training, that's clinically important. That's potentially a sign for a type of vertigo called BPPV, which is common and a very treatable thing in PT, and it's very quick. Don't ignore this. Bring this to your physician and physical therapist if you have this. Pattern 3 is multiple system. This pattern is harder. If it shows up, your performance is below atypical across all 3 tiers. There is no single system that stands out. Multiple systems are below the average. The action, we have to have a multidisciplinary evaluation. Physical therapist and your doctor, the audiologist, they're all working together trying to figure out what's going on. Is this a problem that we all can solve together or as a whole team? And then we have the pattern 4 is balance across systems. This is one of the most we want to see. You're going to be across all tiers the same, and you're quite high for all of them. The clinical action for this, You just keep doing what you're doing. Keep doing exercises, keep testing the boundaries of your balance, longer hold times, adding single leg stance with dynamic movements. And then there's pattern 5, sensory profile, incomplete. This shows up when you started an assessment but you have not finished all the 3 tiers. You can't generate enough to have a full profile from partial data. The clinical action is simple. You just come back and keep doing it. So there's 5 patterns. Each one is honest about what your data shows. Each one comes with a specific clinical action steps, and every result you can help map those. Okay, we've talked about the clinical thinking and the features, and now let's take some time to how that actually was built. The methodology is part of what makes it trustworthy. This tool was built using what I call the three tool workflow. 3 separate AI tools, each doing a specific job. Tool 1 was Claude Chat. It was a conversational AI. You might have heard about those, called chatbots. I've used this for the planning and design stages. Here's what planning and design looks like. We start doing a session by talking through what we want to build. What's the goal? What's the user trying to accomplish? What are the design decisions? What are the clinical considerations that matter? Claude Chat helped me think clearly. It would surface options I hadn't considered. It asked me clarifying questions when I was being vague. I would draft different documents that I could hand off to the next tool. Critically, Claude Chat never wrote any production code, never touched the website. His job was thinking. Tool 2 was Claude Code. This was a different AI tool that can actually write and read code on my desktop computer at home. Here's how the workflow with Claude Chat went. Well, Claude Code went. By starting this session by handing it a prompt that Claude Chat and I had drafted together. The prompt would describe what I want to build, what I need to verify before building, and what to check after building. Claude Code would start by doing what I call diagnosing. Read-only investigations. What does the existing code look like already? Where does the relevant logic live? A pattern already established. It would report its findings back to me. Then the part that was really important, Claude Code would hit what we call a stop gate. It would say, here's what I propose to change. Here's the decision I need approval on. What you call. I would review the proposal. I would approve, edit, reject one, sometimes send things back for redesign. Only after explicit approval would Claude Code actually start implementing. The implementation, then pre-commit verification, checking that the code actually does what it claims. Then a final approval before pushing it to the live website. Every single change went through this gate. The tool number 3 was Claude in Chrome. After code went live, Claude in Chrome would open my real browser, navigate to the website, click around like a real user would, and verify the new features actually worked as designed. It would screenshot results, it would inspect the source code, it would deploy URLs, it would report back. Here's what's working, here what isn't. This is different than what I expected. The 3 tools, 3 different jobs, none of them could do all the roles at once. And that's the point. Each phase of the work was independently checked, and I was kind of the mastermind, kind of moving the information around. Now I want to address something that might be on your mind. AI tools for clinical, AI tools writing clinical software. That sounds risky to a lot of people, and I get it. There are real concerns about AI in healthcare. Here's why I'm comfortable with this approach. The AI tools didn't make any clinical decisions, I did. The clinical reasoning, what to measure, how to interpret it, how to present it to users, came from me, a doctor of physical therapy, and with relevant clinical experience. The AI tools helped me think, helped me implement, helped me get in my mind, have a vision of what this is going to be, helped me actually put it on the screen so people can use it. But every decision mattered. It went clinically through me. I want you to know that. The tool you're using wasn't designed all by AI. It was designed by the physical therapist with AI assistance to move faster without sacrificing rigor. This slide is about the specific pattern we used. We called it design conversation. Every single significant architectural design in the tool went through it. 5 steps. Step 1, surface. Cloud Code would do a read-only investigation on the existing code, surface what was actually there, not assuming, actually looking through what it says. Then stage 2 were the options for each decision that was needed to be made. For each decision that needed to be made, Cloud Code would present multiple paths forward. It would tell me the pros and cons of each, not just here's what to do. Here are the 3 things we should do. Here's the trade-off between them. Then step 3 was the suggest. Cloud Code would give me an honest preference with reasoning. I would recommend option A because of XYZ, but option B is defensible if you are prioritizing different considerations. Honest preference, not just whatever you say, boss. Cloud Code would tell me what I thought and was a good idea. Step 4 was the approval. This was the most important step. I would review the options. I'd think about the clinical implications and make the final call. Sometimes I would agree with recommendations, sometimes I'd overrode it because the clinical considerations weigh differently than Cloud Code's understanding. Sometimes I asked for additional options and I threw a curveball and gave it more. Either way, I was a decision maker. Step 5 was implementation. Only after I had given the explicit approval would actual code get written. There was a oh no situation. I'm telling you this one small thing. Every change I had, there was a approval trial behind it. Now, why this pattern? Why not just let code do its thing and check the results later afterwards? Because something software engineers called implementation drift. The gap between what you intended to be built and what was actually being built. It's typical software development. A person designing one part of the code, often different people, and the intent gets lost between them. We solve this every decision with explicit detailed documentation and approval before any code touches the website. So all these things wouldn't go through. So, for example, in this example, we had to go through 8 specific questions before 4EB would be shipped. And these are very specific aspects that had a lot of questions behind them. So we had to talk through all of them, each documented with reasoning, each approved. Now, verification is one of the most important parts of methodology. We went through and walked through this in detail. Every single code change went through 3 phases of verification before being considered complete. 3 phases, not just 1, 3. Phase 1 is the pre-commit verification. This happened before any code gets changed and gets saved into the project. 3 checks. Now this is the first one. We call this the node change. This is the basic syntax check. It makes sure the code can actually set up without crashing. Sounds basic, catches a surprise amount of typos and missing brackets. Second is a git drift review. Git is the system we use to track code changes. The diff shows you exactly what changes what line by line. I would look at every diff before approving the change, not skim. Third is the ES5 compliance GIP. This is more technical. ES5 is an older version of JavaScript that universally supports across browsers, including the older ones some of the older adults still use. We deliberately wrote the entire tool in ES5 to make sure it would work on a wide range of devices. The grip check confirms we didn't accidentally use modern JavaScript syntax that might break the old browsers. Phase 2 is a pre-push verification. This happens before code gets sent to the live website. 3 more checks. So first, I'll approve the diff again. Not the same diff as before. This is cleaned up version. Any fixes from phase 1. I look at every different line and support time. Second is specific files that are being identified. I confirm the files that are being deployed. The ones are expected. No surprise additional changes and no uh-ohs. There's everything that's how I want to know is going to be fixed. And then third is the cache bust is bumped. So it is a way to keep the web browser up to date. Web browsers store local copies of the code. That's called caching. The problem is when the file changes, the browser sometimes keeps the old copy and doesn't load the new one. The fix is adding a version number to the URL file. When the version changes, the browser knows to grab the new copy. We bumped cache busting every document so users always see the latest version. Phase 3 is post-deployment verification. This happens after the code is live on the website. 3 final checks. Cloud and Chrome opens the web version, visually inspects it every page, clicks through it around, checks everything, captures in screenshots if needed. Second, Cloud and Chrome does a source code audit, and so make sure that everything is matching where it's supposed to. Then third, I go through it. It's going to be making sure it looks good in my eyes, and the real interpretations are live. So there's 3 phases, 9 checks total, every code change. That's a lot. It's different. It's deliberately a lot. Most software gets 1 layer of verifications, often just the pre-commit check. Some software gets 2, almost none get 3, and that's what we do. Why I'm telling you this because trust the clinical tools doesn't come from someone saying trust me. It came from underlying methodology being rigorous enough to actually warrant trust. 3 phases of verification, and every change, this is what it looks like. This is the actual delivery record, the complete trial of code changes that was built, the 3-tiered balance system. 29 commits to the main code repo. 3 days, direct pushes, meaning no separate branches that are bearing changes. Every commit to the main line of development, every chain was visible. Now let me explain what you're looking at on the slide. Each row is 1 commit, 1 specific change to the code. The leftmost column is the commit hash, which is the unique identifier. Anyone across the code repo can look up hash and see exactly what's changed during that commit, down to the line. The next column is the phase. You can see how the phases progress through the time. The newest comment, the top, was phase 5A, and then so on, and went lower and lower. Then the third column is the commit message. It describes what the comment did in a specific format. The first word in the parentheses tells you the type of change. A feat means the feature was added. Fix means the bug was fixed. Refactor means the code was reorganized without changing the behavior. Docs means documentation was updated. A chore means a routine maintenance task was updating cache version numbers. After that, the colon got a brief description of what actually visibly changed. This format isn't something made up. It's called conventional commits, and it's widely used in software development. Following it names history, easy to read by audits from everyone. Now, I want to point out a few things about this list. As you see, the development cadence happens most recently. What happened earlier in the development, you can literally trace it backwards in time. Second, the mix of feat and fix. Real software development isn't just about features. A lot of it is about fixing the problems of existing features. And remembering the fix comments in phase 4s. Tell us how careful refinement worked. Third is the commit association between the phases. It's not random change, it feels like nothing. So, all this information is public. The code repo is publicly accessible online. Anyone can trust and look at it on your behalf. You can look at every single commit, read it, and change it. Trust the clinical tools shouldn't be blind. It should be earned. And this is what the earning process looks like, transparency. Let me walk through what you will actually see when you use the tool. The moment you open the website, the moment you walk away with a clinical insight. Step 1, you open the dashboard. You log into AG102. You see the dashboard. You see the 5 pillars of your physical health. So, there's 5 pillars: cardiovascular health, strength. Then there's going to be your stability pillar. Once you click on the stability pillar, it has a number. Once you click on the stability pillar, it opens up to being how you actually got that number for your stability. So this is by design, trying to make sure that you understand what is making of your stability. The very top of that is your century profile. And why is that on the top? Because that's the most actionable thing you can do about your balance. If you only have time to read one line about your balance, it should be your century profile. And that's the line you want to see. Then you can read the profile one section at a time. You can see if you're vision dependent, your balance across systems. You can see the date it was taken. All this was in plain language. And then with this, you can then scroll down and see individual tests what you've done. And you can expand the tests as you see fit. And this is not just generic advice. This is age-based norms that helps you identify where you stand. Now, there's 4 steps. Open the app, click the stability, read the profile, expand the data. Each step adds information without overwhelming you. This is what was built. This is what you'll see when you're using it. Let me directly compare what you've get to a standard balance assessment versus what you get from a 3-tiered balance system. And this is what is the comparison can be so vivid. The standard balance assessment. You walk into the clinic, the therapist just asks you to stand on one leg. They time you, write down your number, they compare it to a chart and tell you you're the 30th percentile for your age. They give you some balance exercises to go home with. End of session. While you walk out with one number, 1 percentile, one generic exercise, and that's it. Now the three-tiered balance system, you do the assessment. You maybe spend 20 minutes walking through all 3 tiers, each with 5 positions. The system records every trial, every support level, every detail. What you walk out with, and remember, is this is what actually is on your screen, is your sensory profile pattern. The system identifies whether your balance is leaning towards vision, inner ear, or struggling across multiple systems, or your balance is good across all 3. And this is a way of general information. Again, this can't be medical advice, but this is just, but it can be more specific than that. Your achievement level, even if you didn't reach single leg, you have a recognized level. It's not a failure. You're a builder or a climber. You're somewhere on the progression. Your training recommendations, not you're doing some exercises, your specific guidance. Focus on eyes closed, standing on foam. Avoid vestibular stressing exercises until you are improving your vision and reassess. This is what your screen says. Your supporting data, all the 5 positions, 3 trials for each, 2 sides, 3 tiers, all visible, all organized, all available for you and your therapist if they want to dive in deep. Then your reassessment history. Did this last month, a few months ago, the trend is visible. You can see if you're improving or declining. This is fundamentally different than any clinical tool. Now I want to be clear about something. I'm not saying the standard balance assessments are wrong. They're doing what the best they can with the tools I have. I've used them my whole career. But for the older adult, being Pacific, who are often dealing with multiple things at once, we can benefit from this framing. And comparing isn't about which tool is better and fancier. It's about what tools it gives you the most useful information. Standard balance test, one number that may or may not lead to useful action. The 3-tiered balance is a clinical interpretation and recognized achievements. So it's motivating for you to keep coming and trying to progress through the things. All from the same foundation data, but progressed and presented in a way that helps reward and make something more meaningful. I want to spend a few moments on the scientific foundation of this tool. As we talked about in the earlier phases, we did a lot of deep dives, and so these are the foundations of these tools. And so we can't forget all this is from research, and there's a lot of references between the older adult and younger adult to make this improve as best as we can. These are the 4 key learning from this development, things I'll carry forward in the future work, not just this tool, but for anything I build next. Learning 1, find out before scoping. This sounds obvious, but it's not. Early in development, we'd sometimes try to design fix before fully understanding what the current code did. We'd write it up, we thought we fixed it, hand it off to Claude, and then the Claude would discover during the implementation that it was different than what was expected. So we have to redesign, and it made things very slow. We learn to do read-only diagnosis first before diagnosing any fix. Cloud Code would read the existing code, tell us what's actually there, and design it based on facts, not assumptions. Learning 2, decisions gates work. Phase 2 had some stop gate patterns, where the Cloud Code presented proposed changes. The gates did a great job. I really loved how they worked. Then learning 3, trust no comment until verified. So we have to make sure we are completing different cache checks, and because a lot of times we're loading old caches, and that is quite frustrating. So making sure we trust and verify everything. Learning 4, honor a clinical reality in UX. This is the most important one for clinical software specificity. Most software UX is designed by people who haven't worked clinically. They optimize for things like aesthetics, brand consistency, conversion rates. Those things matter, but they don't capture the nuance of clinical reality. Our tool, the difference between skip and not attempted matters. The difference between level A versus level E support matters. And that's why I was all about this. So 4 learnings, each one shapes how to approach the next phase of development. These aren't lessons for the tool. These are lessons for building and things that I've learned throughout this process. We've covered a lot of ground today with the 3-tiered balance systems, and I want to make sure we are finding that we can have older adults understand and learn their own balance. I always like to say, I can give them a fish and they eat it for a day, but I want to teach them their fish so they understand their balance and they can eat the rest of their life. And this is the 3-tiered balance systems, and we're going to go through the next aspect and some additional benefits for people who might want to test the boundaries a little bit. So, as we talked earlier, we remember the 3-tiered balance system, and now with this in this series, we're going to be upfront. What's the next chapter? We took that foundation and what was built from the 4 and built the 4 advanced tracks on top of it, focused on the feet and ankles, and in doing so, we changed balance from something we measured on the side to the engine that drives the person's stability score. Let me show you how we did it. Let me quickly remind you where the foundation left off. We tested balance 3 ways: eyes open, eyes closed with head turning. Across 4 positions, narrow base, the feet together, all the way up to single leg stance. We grounded and graded how much hand support someone needed, and we recognized progress on a ladder that tops where someone can call a balance champion. Reaching balance champion across all 3 tiers is a doorway to everything I'm about to show you. Because at that point, you ask yourself, and we want to keep you improving your balance. Like, oh, I reached the top tier aspect, what are we going to do? So I'm about to show you how well your feet and ankle are going to respond to this. This is a whole shift. The foundation measured how you sense. T4 measures how your feet and ankles respond. Here's the gap that tier 4 fills. Your senses, your eyes, your inner ear, and your body's position sense are your alarm systems. They tell you your starting point. The foundation we built measures how good that alarm system is. So think about it. Detecting a wobble is only half the job. Something has to actually catch you. That's what something is. Mostly your feet and your ankles. Research calls this the ankle, the first line of defense in balance. Tiny little muscles in your feet and ankles are making constant little corrections all day to keep you centered over your feet. So a fall isn't just an alarm that doesn't go off, it's also a response that doesn't fire or fast enough as well. The tier 4 is all about training and testing that response. Here's the whole family at a glance. 4 tracks, at each one catches a different way people lose their balance. Track A is foam, standing on an unsteady surface, which takes away your sense of footing. Track B is toes up. You lift up your toes, which loads the muscles in the front of your shins and challenges you from falling backwards. Track 4C is heels up. You raise on the balls of your feet, which loads your calves and challenges you from falling forward. Track D is arch lift only. We hold your active arch and wake up those deep little muscles inside your foot. Why 4? Because people fall for different reasons. Each person has weak ankles. One person has weak ankles, other has numb feet, the other can't control small foot movements and muscles. Each track catches a different one, so together they give us a full picture. Let me show you a small ideal that does a lot of work. The foot tripod. The foot rarely stands on three points. You heel, the ball of your foot by your big toe, and the base of your little toe. These 3 points make a triangle or a tripod. This is your stable base. Now for two of our tracks, toes up and arch lift, we require the tripod to stay down the whole time. Here's why. If you're doing toes up and your heels start lifting, your foot's going to roll to one side and you're not really doing the toe up variation with you're cheating. Usually curling your toes and rolling onto your edge of your foot. So this way is of making sure that people keep the tripod and stay grounded. If you don't, the hold position doesn't count the same way. The tripod is how the system tells a real hold from a clever workaround. Track 4A is the foam pad, and it comes from the 2 reasons. The clinical reason, when you stand on foam, the ground stops, giving your feet clean information. It's like standing on a soft sand or a thick mattress. Your balance has to learn more from your eyes and your inner ear, and then your foot. That is a well-established way of a challenging balance. The practical reason 4A comes first. It was the track that built the road. It set up how data gets saved, how the session flows, and how balanced results feeds the score. Once built, the other ones can be driving off the same road. They plugged in the same designs without having to rebuild anything. Foam built the road, toes up, heels up, an arc drove down the same thing. Track 4B is toes up, and it's about guarding against falling backwards. There are actually 2 versions. The standard one where you lift up your toes but keep the ball of the foot and the ball of your big toe and your little toe to keeping the tripod down. Then that works on the muscles on the front of your shin. The one that lifts up your foot when you walk. When you do in all 4 positions, from feet together to one leg, there's a bonus version that gets generally very hard. You lift up your whole forefoot, so you're balancing on only your heels. I tested it out myself. It only lasted 5 seconds because it's so demanding. It only offers 2 awards. Why does this matter? Because the ability to lift up your foot is the foundation of walking, and the ankle is your first line of defense against the fall. Weakness in the toes and the feet is one of the things that actually protects us from Track 4C is heels up, and it guards against falling forward. You raise up on the balls of your feet, which shifts your weights forward and really loads your calves. This tests the front edge of your balance, the place where toe and forefoot strength matter the most. Now, 4C has a wrinkle. I want you to understand, standing on the balls of your feet tires your calves out fast. So if someone steps down, we have to ask, did you lose your balance or did your calves fatigue first? Those are 2 different things. And reading this track means telling them apart. It's also the tippiest position of all 4. So a wall and a spotter aren't optional here. Why does that matter? Toe and forefoot weakness is the biggest predictor of falls we have. And there is a well-studied heel raise test that loads the calf muscles and has a solid age and sex-based norms which means over time we can anchor this number to real reference data. Track 4D is the arch lift, and is a subtle subtest of the 4. Instead of challenging your position and holding your arch active, we call this the short foot, which wakes up the deep little muscles inside the foot and the muscles that support your arch. These are the muscles that quietly steady every step you take. Because it's subtle, we use 2 checks. First, the tripod to stay grounded. That's how we know you're not cheating. By curling your toes, rolling your foot. Second is the highest level you can have to hold that arch. This is the mark of mastery. Why does it matter? Research shows the small muscles of your foot are a significant tie to whether you fall, and training them improves balance. With your eyes closed and older adults, here's the nice connection. This track is basically the test of exactly what our foot health week already teaches. To train, this is the subtest track of a active muscle hold, not a gross position. This tripod keeps you honest. Every track uses the same ladder, so once you learn it, you recognize it everywhere. Steady is feet side by side. Adapter is tandem, one foot slightly in head. Master is tandem and heel to toe, and champion is standing on one leg. Each rung asks you for a narrow stance, held time, target. 2 things I won't compromise. First, you have to earn every level with both legs, not just your good side. Real falls don't let you pick which side you're going to catch you on. Second, I want you to be honest about the time targets. The 20, 15, and 10-second cutoffs are a starting point. They're clinically reasoned, but they don't have any valid research against huge samples yet. So we're flagging them as provisional, and so we'll define them as real data comes in. I'll rather tell you that plainly than pretend those numbers are settled. Now the change that made all this matter to your actual score. Before, balance was something we measured on the side. It informed the overall picture, but it didn't really drive your stability number. Everything was sort of thrown in a pile and averaged over a redesign. Your balance performance feeds your stability score directly. It does through what we call the weighted buckets. That just means the pieces that matter the most for keeping your feet counted is more. So the number that you actually see reflects the real balance ability, not just an average of unlike things, and the weight isn't arbitrary. This is clinical choice. What matters most to real world falls and carries the most weight. This is how the advanced work feeds to your score. We call it the bonus stem. Every tier 4 badge you earn gets you 3/4 of a point to your stability score, building towards a cap. There's a lot of badges across the 4 tracks, so there's a lot of room to climb if you put in the work. Here's the part I'm real proud of. Behind the scenes, we designed the connection point early, before we strictly needed it to. And because we did it, every one of the tracks gets plugged into the score without a single line of code. No rebuilding. That's the real payoff. And design to join before they need to. And for you, the 3/4 point bonus is a rewarding for you to take on the harder optional work. The reason to keep on going. I want to be straight with you about what's proven and what isn't, because I think that honesty is strength. The reasoning behind every track is solid. The system involves the muscles, the ways people fall. All this is backed by published research. But the specific cutoff times, 20, 15, 10, those are clinically reasoned starting points. We borrowed them from the foam track as a sensible place to begin, and we'd flag them as provisional. As real data comes in and from people using the platform, we find them, and from the heels up track, we can eventually anchor to well-studied foot raise tests. I'd rather tell you exactly what rests on evidence and what rests on my clinical judgment than pretending it's all settled. That's honesty, and that's the point. Two smaller updates that come out of this work. First, a name change. What we called the Century Contribution Profile is now Century Compensation Profile. That word compensation is more honest. It names which system is doing extra work to cover up that slipped. We changed it everywhere, including in our master reference document. Second, we added a new pattern. The old version recognized 5 patterns of how people balance. Now there's a 6th. Surface dependent. For people who do just well on solid ground but struggle the moment the foot is unsteady. And that's the foam track. That surface, this pattern, which is fitting, so a cleaner name and a more complete map of how people can keep their balance. Here's something that doesn't show up on the screen but matters enormously. Documentation. Every clinical decision in Tier 4 WINT got written back into the master reference document, which is now on version 10. The document is a single source of truth of how the platform interprets every result. Version 10 captures all the 4 tracks, the scoring redesign, the bonus stem, the name change, the section of honesty tracks, these provisional thresholds, and all the one rule throughout. If one old design it disagrees on it, the actual gets shipped, the code wins. Because the code is what actually experiences for users. We don't just assume it was right either. We cross-check every single time thresholds in the document against live code. The documentation finally matches the platform. If you saw the first talk, this will sound familiar. We use the same careful workflow. Three tools, each has one job. One for planning, one for clinical decisions, one for writing the code, one for checking the results in the real web browser after it went live. The habits carried over too. We always investigated before changing anything. Every decision had an approval gate. We did the same thing at the time. Nothing gets drifted. We push straight to the main, so no side branches. We check every time, so nothing drifts. Deployment is on in a fresh browser because an old cache file can make something look broken when it's not actually. The rule underneath of all, what actually ships is the truth, and the documentation gets reconciled to match. That discipline is exactly why you can trust the numbers you see. Let me show you what actually looks like to use. First, you unlock it. Reach balance champion across all 3 tiers. That opens up tier 4. Then you pick a track, foam, toes up, heels up, arch lift, each with its own ladder to climb. 2 small touches I can care about for the users is you want help. If you need more guidance, videos are right there that I filmed to help with one tap away, but it's never shoved in front of you if you don't need it. And when you finish a test, the app website brings you right back where you started from, so you never lose your place. That sounds small, but for users, friction is what makes people quit. Smoothness matters. I want you to see the reasoning behind everything I do, and everything is backed by real research. The link between foot weakness and falls comes from Makal's work. The ideal ankle is your first line of defense. The heel test you can all anchor to comes from Iana. The foot core evidence comes from two recent studies showing that the little foot muscles are tied to falls, and improving them can help reduce your falls. Foam logic comes from established balance test called the mini best. The ideal of holding toward 30 seconds rather than stopping at 10 comes from research showing longer hold times tells us more about falls risk. The point is simple. Every number, every interpretation in the system traces back to a source. You can go read it yourself. It is not a trial. It's not a claim. It's a trial and not a claim. Here's where things stand. All 4 tracks are shipped. Foam toes up with its bonus, heels up, and arch lift. Each one feeds onto the score. Balance now, fully derived in stability pillar, and now it's documented in each version of a reference. The balance system itself is finished. As far as what's next, there's a lot of stuff we can be going on. But there's a standing heel test with great normative data, but it measures calf strength, not balance. So it belongs in the strength pillar, not here. We're rolling out more instructional videos across the track and all the other pillars. Cardiovascular, mobility, power become more candidates for the same depth of treatment. So this is a finish of this aspect, but there's lots of steps ahead. So at the glance view of the stability pillar, what you see at the moment you click onto it from the dashboard, this changes from the real user concern from a concern who was right. The old display was a bare number. Tier 1, 66 seconds. Tier 2, 66 seconds. What does that mean? What position? How much support was used? What was the leg that you're on? You couldn't tell. And the number was a support blind. Someone gripping the wall identically as someone with no hands. The redesign unpacks it. Your century system at the top with plain language interpretation. Then your overall balance, your achievement on the wall, your three-tiered foundation shown once above in a table because the achievement was global, not per tier. The center table itself shows you for each tier, position you reached, hand support used, and best single leg stance with what side. In this example, single leg, level 3, 66 seconds on the right and the left. Some number as the old display, but now you can read it, the whole story behind it. This person reached single leg stance everywhere with no hand contact, and their left leg is a strong side. Below that, the tier 4 appears once at the badge is earned. 4 tracks here, 3/4 of a point for bonus with a claspable viewed in one screen. This was achieved, and what support and what was the old piece. Now what happened when the participant clicks learn more? The panel expands to 2 parts, separated by a clear visible gap. The top half is a pattern-based program guidance, what to train based on the user's sensory pattern. That part been there the whole time. What's new is the gap. We spaced it out a little bit so it's read a little bit easier. Your tier 4 progress, a bullet point for each badge. Your participant earned. The badge was bolded so you could scan it, the list, and then clinically grounded sentence telling you what the achievement reflects. Foam reflects steady balance on unstable surface. Toes up reflects shin control and resistance to fall backwards. Heels up reflects your ability, your calf and your foot strength, guarding against forward falls. Arch lift reflects the deep foot core muscles that quietly steady every step. This list shows some of the tracks that participants can
and grows as the participant progresses. Someone who climbs the steady to master foam sees the update automatically. The template works for any level of any track. Every clinician claim is grounded by real research. Maka, Taham, the BMC, geriatrics, work for the foot core training. They all have real research behind each point. So, at a glance, tells you what you've achieved. The Learn More panel tells you what you're training and why. Together, they replace one peak number that with a full clinical story. So that's the 4-tier family. Advanced foot and ankle tests and tracks that took balance from something we measured on the side and turned into an engine of stability score. One cohesive system built carefully and honestly with proven information, and it has to be well calibrated. Thank you for your time. I'd love to take questions. My contact information is on the screen. Feel free to scan the QR code to get to my website.